Hello guys, welcome back to Godwin. Today we'll be talking about the regulation of glycolysis. In our last video, we talked about the process of glycolysis. So if you've not watched the video, please make sure you watch the video. And so today we'll be talking about regulation of glycolysis. I will be discussing regulation of glycolysis and the energy yield in glycolysis. Now, so here, in our last video we talked about that there are three main enzymes that are highly regulated in the process of glycolysis, and these are glucokinase, hexokinase, phosphofructokinase 1, and pyruvate kinase. So these are the enzymes that are highly regulated, and this enzyme catalyze step 1 and step 3 and also step 9 of the process of glycolysis. So here, let's start with hexokinase. How is hexokinase regulated? Before that, don't forget there are two types of regulation. We have the hormonal regulation and the allosteric regulation. So the hormonal regulation has to do with insulin and glucagon, how they affect these enzymes. All right. So here, when the level of glucose in the human body increases, this glucose stimulates hexokinase. All right, it stimulates hexokinase to phosphorylate the glucose into glucose phosphate. So we can say that glucose is a stimulator of hexokinase. So I'll be writing the stimulators in the blue pen and the inhibitors in the red pen. All right, so here glucose is a stimulator. Glucose is a stimulator of hexokinase. Now, what happens now when the body is low in glucose? The body releases glucagon, a hormone, which then inhibits this enzyme hexokinase, stopping the process of glycolysis. Since the process of glycolysis is breaking down glucose in the human body into ATP, which means the level of glucose in the human body drops. Now, glucagon is released. So we can say glucagon is an inhibitor because glucagon inhibits this enzyme from phosphorylating glucose into glucose phosphate. So here we're going to write glucagon as an inhibitor. Glucagon. All right. Remember, when we eat food, all right, and glucose is being produced, the body releases insulin. What is insulin done? Insulin dephosphorylates, like what these hormones does is insulin dephosphorylate, carry out dephosphorylation and phosphorylation. That's what hormones actually does in the human in the process of regulation. All right, so insulin is released, and insulin also catalyzes this hexokinase to phosphorylate glucose into glucose phosphate. All right, so it catalyzes the breakdown of glucose also in the human body. So we say insulin is a stimulator. Insulin is a stimulator of this enzyme. Remember, glucokinase is found in the liver. All right, so glucose increase in the human body also stimulates glucokinase in the liver to phosphorylate glucose into glucose phosphate. So the stimulator of glucokinase is also glucose. All right, it's also glucose. So one of the inhibitors of this hexokinase also here is glucose phosphate. Now remember, when a lot of glucose in the human body is being phosphorylated into glucose phosphate, which means a lot of glycolytic processes are happening in the cell. So they will have a lot of glucose phosphate. All right, so glucose phosphate would inhibit a feedback inhibition. All right, so it will inhibit this enzyme from phosphorylating glucose into glucose phosphate. So glucose phosphate is an inhibitor of hexokinase. So glucose phosphate inhibits. All right, let me clean this one up. glucose phosphate, I'm going to abbreviate that in GCP, glucose phosphate. All right, so glucose phosphate inhibits hexokinase by feedback inhibition. All right, so let's go back now to glucokinase. Now, what stimulates glucokinase? Also insulin. Insulin also stimulates glucokinase. Insulin also stimulates glucokinase. So here we have insulin. All right, insulin also stimulates. Then fructose phosphate stimulates glucokinase. So fructose 6 phosphate. All right, fructose phosphate stimulates insulin, and remember they are always inhibited by glucagon when the level of glucose in the human body drops. Glucagon inhibits this enzyme, preventing it from phosphorating glucose into glucose phosphate. So glucagon is an inhibitor of this process. All right. Remember, fructose phosphate is an inhibitor of this process. It's not a stimulator. All right, sorry about that. So fructose 6 phosphate is an inhibitor because now, since the process of glycolysis, we have lots of fructose phosphate, so which means the process of glycolysis is actually going smoothly, and the level of fructose phosphate is increased in the human body. So fructose phosphate inhibits this glucokinase, preventing it from phosphorylating glucose into glucose phosphate and then to fructose phosphate. So fructose phosphate inhibits hexokinase. All right, so these are the stimulators and inhibitors of hexokinase and glucokinase. So now let's move into the next enzyme, which is what? Phosphofructokinase type 1. Phosphofructokinase type 1. The greatest stimulator of this enzyme is fructose bisphosphate. Fructose bisphosphate. Remember, I told you in the last video that fructose phosphate, a little amount of it goes through a different pathway, and it will be phosphorylated by phosphofructokinase type 2 into fructose bisphosphate. All right, so fructose 2,6-bisphosphate then come and what increases the activity of phosphofructokinase type 1. All right, so the stimulator of this enzyme is what? Fructose 2,6-bisphosphate. Fructose bisphosphate. All right. Now, what happens when the level of glucose in the human body drops? Glucagon will also be released, and glucagon comes to what? Glucagon phosphorylates this enzyme. Remember, this enzyme is the one that converts fructose phosphate into fructose bisphosphate. So glucagon phosphorylates phosphofructokinase type 2, and it deactivates it. So phosphorylation of this enzyme deactivates it. All right, so since this enzyme is deactivated, which means there's a reduction in the amount of fructose 2,6-bisphosphate. All right, so glucagon inhibits these enzymes. So our inhibitor here is glucagon. All right, so what about in a situation where the level of glucose now increases? What will happen? Insulin will also be released. And what insulin does is that insulin dephosphorylates this enzyme. Since phosphorylation of this enzyme deactivates it and causes a reduction in fructose 2,6-bisphosphate, then the dephosphorylation of this enzyme will make it active also. So insulin activates this enzyme by dephosphorylation. So we say what? Insulin increases the activity of phosphofructokinase type 1. So put insulin here as what? As a stimulator of this enzyme. All right. So another stimulator of this inhibitor of this process is a very interesting compound. All right, very interesting compound. Inhibitors of the compound, we have what? The citrate. Remember, citrate is an intermediate of the Krebs cycle. All right, remember when these processes are going through, which means a lot of Krebs cycle activities are going on to yield what? ATP. All right, to yield ATP. Remember, if there is lot of citrate, a citrate is inhibiting this enzyme already, which means a lot of Krebs cycle activities are going on, and we have a lot of ATP given off at the end. All right, so if the level of glucose also drops, and we want to stop the process of glycolysis and Krebs cycle, so citrate comes and inhibits this enzyme, preventing it from phosphorylating fructose 6-phosphate into fructose 1,6 base phosphate. So citrate, an intermediate of the Krebs cycle, inhibits this enzyme. All right, remember, in the Krebs cycle, it has to produce ATP, and ATP is produced, and the electrotransport chain also. So ATP, when there's a lot of ATP in the human body, like a lot of energy, which means there's a lot of glycolytic processes occurring in the human body, ATP inhibits fructofructokinase 1. All right, so ATP is an inhibitor of this enzyme because a lot of ATP are in the body and a lot of glycolytic processes are occurring. So this ATP inversely stops this process because they say, oh, we have a lot of ATP in this body already. So ATP comes and inhibits this enzyme, preventing it from phosphorylating fructose 6-phosphate into fructose 1,6 base phosphate. Remember, and now, when the level of ATP drops, which means ATP is being broken down into ADP. Remember, ATP can be broken down into ADP and AMP. All right, which means there's a reduction in the amount of ATP. So AMP and ADP are being produced. All right, so this AMP and ADP comes to this enzyme. They say now the level of ATP in the human body has dropped, and we want you to carry on with the process of glycolysis so that we have a lot of ATP in the human body again. So AMP and ADP increases the activity of phosphofructokinase type 1. So AMP and ADP are the stimulators of this enzyme, while glucagon, citrate, ATP are the inhibitors of this enzyme. All right, so these are the stimulators and inhibitors of phosphofructokinase type 1. Then let's move right now to the last enzyme here, pyruvate kinase. Pyruvate kinase. Pyruvate kinase is stimulated by insulin also. Remember, insulin stimulates pyruvate kinase because since there's a lot of glucose in the human body, insulin will be released, and insulin catalyzes this, increases the activity of this enzyme, making it to phosphorylate phosphoenolpyruvate into pyruvate. So insulin increases the activity of this enzyme, so it activates it or stimulates it. Then another inhibitor of this enzyme is glucagon also. Glucagon inhibits this enzyme. Glucagon inhibits this enzyme. And very interesting, fructose 1,6 bisphosphate. Fructose 1,6 bisphosphate comes all the way from here to stimulate this pyruvate kinase. How? This is in a feed-forward reaction. A feed-forward reaction or feed-forward stimulation. Because now, since we have lots of fructose 1,6 bisphosphate, all right, lot of fructose 1,6 bisphosphate, which means a lot of glycolytic processes are occurring in the human body. So this compound comes all the way from here to increase the activity of this enzyme so that the glycolytic process can go on smoothly. So fructose 1,6 bisphosphate stimulates this process. Fructose 1,6 bisphosphate. Fructose 1,6 bisphosphate stimulates this process. Now, the last inhibitor of this compound the last inhibitor of this compound. Remember, we said glucagon is always inhibiting most of the enzymes, like we've mentioned here. Glucagon inhibits it, and now the last inhibitor of this compound is ATP. ATP. When there are a lot of ATPs in the human body, so ATP what comes here, like in the in the backward inhibition, inhibits the activity of pyruvate kinase, preventing it from what conversion of phosphorylation of phosphoenolpyruvate into pyruvate. So glucagon inhibits this enzyme. So these are the stimulators and inhibitors of the glycolytic pathway. So this is how glycolysis is being regulated in the human body. So let's now go to the energy yield in glycolysis. In step 1 and in step 3, we find out that what ATP is what being broken down. ATP is being broken down into ADP. ATP is broken down into ADP. So in step 1 and in step 3, ATP is broken down. So we used up 2 ATPs here. So we ended up using, we used 2 ATP in this process. All right. Why in step 6 here and in step 9, we produced 2 ATP respectively. 2 ATP. So we produced 2 ATP respectively. So 2 ADP is broken down into 2 ATP. So 2 ADP here is phosphorylated. So ADP is phosphorylated into ATP. So produce 2 ATP here, and we produce 2 ATP here. So 4 ATPs in total were produced here, and we used 2 ATP in step 1 and step 3. So the net energy yield in the process of glycolysis is 2. Net yield equals 2. So 2 ATP. 2 ATP are produced in the process of glycolysis. A net yield of 2 ATPs are produced in the process of glycolysis. So guys, this is the process of regulation of glycolysis and the energy yield in glycolysis. So please, if you've not subscribed to my channel, please make sure you subscribe to my channel. Please share, like, and also leave a comment in the comment section down below.